This is my 6th video on using protease for first year engineering students. This is the continuation of my video number 5. In the last video, I showed you how to solve simple current divider circuits. In this video, I'm going to show you more examples. It's a kind of a complex circuits, and again, the circuits is not going to scare. It's not complex. It's just like a, I would say like a medium complexity. So this is the kind of circuits we discussed in the last video. These are the simple ones. So you're given the current source and you've been asked to find the current in these two branches. So the formula we use is the current in a branch is equal to the other resistance divided by total resistance times the current, which is 3.63. So again, the current in a branch, or the current I2, is the value of the other resistor divided by total resistor times the current. That will give this much. Sometimes, as I mentioned in my previous videos, you can also take away the first current from the total input current. Sometimes for some students, they find it easier when the circuit diagram is given in this way. Both are the same circuits. It's just the way the resistors are laid out in the diagram. Say if you look at here, the current I splits into I1 and I2, whereas here the current I splits into I1 and I2, and this current I1 and the current I2, they both join at this node, getting you back the current I1. The same thing, the current from I2 and the current from I1, if you consider at this junction, apply your Kirchhoff current law, so this must be equal to the current I. So these are the straightforward circuits we can work out. So there are few things, if you remember, will help you solve the circuit easy. So you already know this concept. I have got here the parallel resistors of the same value, R and R. Now when you apply the formula to find the equivalent resistor, which is 1 by RT is equal to 1 by R plus 1 by R. So when you simplify, you end up getting 2 by R. And when you take a reciprocal on both the sides, the total resistance of this parallel circuit will be R by 2, which is half the single resistor. So now you know when the resistors that are in parallel having the same value, the equivalent resistor is always half of one of the resistor. Take this as an example. So to find the equivalent resistance, you got the parallel, branch with the same resistor, 10 and 10. So the equivalent resistance will be 5. So you end up replacing this parallel resistors with the corresponding equivalent resistors, like 5 ohms here, like I have shown here as well. The equivalent resistor is R by 2. And okay, one more tip, the current divides equally. So when the branch resistance are the same, so for example here I got the 5 amps input current, because the resistance in the parallel branches are the same, the current divides equally. You'll end up having 2.5 amps here and 2.5 amps there. You can apply the division logic when you have more than 2 branches. So take this as an example. So I've got input current which is 5 amps, and the branch resistors are all 10 ohms. So you can just get the equivalent resistor by dividing 10 by number of branches. Take any one resistor value. Here it's all the same. Divided by 3. So the equivalent resistance of this parallel branch will be 10 by 3, 3.33 ohms. You can just replace this parallel branch with this single equivalent resistor. And obviously the current will also get divided equally, because there are 3 branches. You will end up dividing the input current by 3, which is 1.67 amps. You can extend this for 4 branches. So equivalent resistance will be 10. Just take the resistor value here, divide by number of branches, that gives you 2.5 ohms. So you can replace this with a equivalent resistance of 2.5 ohm. Then the current in all the 4 branches, I1, I2, I3, I4, they all be equal to 5 divided by number of branches, so 1.25 amps. So you can just these are some of the tips, if you remember, maybe you can, if you are given a 1-mark question, you can easily answer them. Okay, I got one more problem here. You have been asked to find the current in all the branches. So a problem like this, you first have to understand the circuit. So we have a current source and we have got some combination of resistors. You have been asked to find the current I1, I2, and the same current I2 flows here as well, and the current I3 and I4. The same circuit I can also write in this way. Both are the same circuit. So first give some thinking on how the current is divided. So the main current, input current I, first divides into I2 and I1, which is at this junction. Now the current I2 further gets divided into I3 and I4. So you have been asked to find I2, I1, I3 and I4. Now again, there is a dependency logic here. You cannot, if you want to find the value of I3, you must know the value of I2. To find the value of I2, you must know the value of I, which is given to you. So the only thing you know so far is the value of I, which is the 5 amps. So these type of problems are very similar to the way you find the equivalent resistance of a circuit, where you start substituting a parallel resistance with the equivalent resistor and combine 2 series resistors. It's a very similar, it's a very same idea you'll be applying to solve these type of problems. Now here I have to find what is the current I2. So for that I need to first find out the equivalent resistance in this entire branch. Now first thing what I'm going to do is replace this. So I'm going to replace this parallel circuit with this equivalent resistance. Now we already know, because I made this problem little simple by having the same resistance here. We've got 2 resistance, 2 ohms in parallel, so the equivalent will be 1 ohm. We got that here. So this, the equivalent circuit will look like this. You will have 1 ohm, which is this 1 ohm, and the equivalent of this and the 1 more ohm. Now the next step what you do is again start reducing, or so these 1 ohm, 1 ohm, these 2 are in series, so that gives me a 2 ohm here. So now you have got a simple circuit with only 2 branches. So you know how to find the current. So the current I2 is the other resistor divided by total resistor times the input current, which is 1.67 amps. And the current I1 is, you can either do 5 take away 1.67 amps, or you can apply the same formula. You might end up getting a few rounding errors here, but you can ignore them for the time being. So the current I1 is the other resistor divided by total resistor times input current, which is 3.33. So now we know the value of I2, because in order to find I3 and I4, you must know the value of I2. Then you have to backtrack, go back to the circuit diagram here. So here the current I2 divides equally in this parallel resistor. So to find I3 and I4, I2 we know because the resistance are the same. So the current I3 and I4 will be divided into 2. The current divides equally, which is 0.83 milliamps. I made a similar circuit using a Proteus. So here I have again two parallel resistors here, and I got parallel resistors here. And if you want to do this in Proteus, it is a more work than usual because you will end up putting in a lot of ammeters to measure the current. So I got the 5 amps as a current source. I got a 6 ohm resistor here. I just took all these resistors in random. I got 1 ohm and 2 ohm, and I got 3 ohms here. So I can draw this circuit, and when you simulate, so you'll end up getting all the currents in various branches. So what you might have to do is first try to solve this problem applying your logic, applying your knowledge of finding the equivalent resistance and finding the current in a branch, then dividing the current. So you end up doing this on a paper, then compare your results on this Proteus. So I got one more example which I'm going to do right in front of you. So here, to keep the problem simple, I've got the same resistor values in the parallel branches. I've got if you look at it, I got the same 4 ohm resistance here, I've got 10 ohm resistance here, and 8 ohm resistance here. As I mentioned before, you first understand the circuit. Now you have been given the current source, you have been given the value of I, and keep in mind this resistor is not going to have any effect on a calculation because the 5 amps flows here and it reaches up to here. So up to here you have the same 5 amps. So if you look at this diagram, the current I divides into branch I1 and I2, which is these two division. Further, the I gets divided into I5 and I6, which is these two, and I2 at this junction divides into I3 and I4. You get a nice network diagram here, a tree-like structure. And the current I5 and I6, when they both join together, you'll get back the same current I1, because I1 is input current. You have to get the current I1 at this junction also. Now this current I1 so gets divided into I7 and I8. So if you are able to find, if you find this current I1, you can find the value of I5, I6, I7, I8. Now this is the next step you have to do. Now what will be the step by step? The way you do that is, we have got one parallel resistance here. The equivalent resistance will be, I'm going to replace that with 5, we know that. And what about this one? You got 8 and 8, the equivalent of that will be 4 ohm. And this one, you got 4 and 4, the equivalent resistance will be 2 ohm. So this circuit diagram get reduced to this one. So from here you have to get reduced to this. So again, these three resistance are in parallel. You got 2 ohm, 5 ohm, 4 ohm. They are in parallel. Sorry, they are in series. Now the equivalent resistance is the sum of all. This will be 11 ohm. And what about here? You got a 2 ohm in series with the 2 ohm. So that will be 4 ohm. So this is your next equivalent circuit. Now probably you can continue finding the current I1 and I2. So what is the current I1? So the current I, which is 5 amps, gets divided into I1 and I2. So I1 is the other resistor, that is 4, divided by the total resistor, that is 15, times 5. And I2 will be the other resistor 11 divided by total resistance 15 times 5. So if you use your calculator, So you will end up getting, so I've got the current I1 as 1.33 amps and I2 as 3.66 amps. Now you have to find the remaining currents. So first we'll try the current I3 and I4. Because the resistance are the same, I3 will be the same as I4, and so the current I3 I4 will be the current I2 divided by 2, because they are equal resistance, they divide by 2. So that will be, so this will get something around say 1.78 amps. So you are able to find this and that. So how about I5? I5 and I6 are the same. So which is the current I1 divided by 2. See, we already know I1 as 1.33, so divided by 2, you're getting somewhere around 0.67 amps. And if you want to find the current I7, which is same as I8, that will be the same current I1 now divides by 2, so it's the same thing, 0.67 amps. So if you look at this one, even having the 10 ohm resistance and the 8 ohm resistance here, the current in the branch is the same. I could have also reduced this into a 1 ohm and a 1 ohm. You still end up having the same current, 0.67 amps, both. So maybe in the later videos, or I'm going to explain, there are a few plus and minus with these type of things. You should always think about the power, which is I square R. So you should be worried about what kind of power will be generated, because the current is the same. So there is a more power dissipation in a 10 ohm resistance than with the 1 ohm resistor. Now this was the circuit I simulated using Proteus. So you already know how to solve this type of problems. The only difference here is the resistor values is different. So you have to use your calculator to find the equivalent resistance. I'm just going to go through this quickly. So we got the current I divides into I1, I2, and the current I1 divides into I5 and I6, and here the current I2 divides into I3 and I4. Again, you just have to apply the same concept, convert this into the equivalent resistor and convert this to the equivalent resistor. So R1 will be 4 parallel 5 and this R2 will be 1 parallel 2, and I've already computed so this is the equivalent resistance R1 R2. So if you look at here, this is R1 and this is R2, which is 2.22 and 0.67. So your circuit will become like this. And the next step is you have to find out still you cannot determine the value of I1. You have to combine these two resistance and 6 and 0, these two resistance. You'll end up getting this as an equivalent circuit. Now you can find the current I1 and I2. This again, you apply the current divider algorithm where only two resistors are present. So here the current I1 is the other resistor divided by total resistance times the current I, and I2, that will give you 2.80, and the current I2 is, I just use the main current, take away the branch current, you got that. Now once you know the current I1, I2, you have to go back to your original circuit diagram, so which is this one. So you know the current I1 now, you know the current I2 now. You have to divide I1 between 4 ohm and 5 ohm. You just have to apply the same step. So I3, if you look at this here, I3 and I4, I3 is other resistor divided by total resistor times 2.22 input current. You will get this, and I4 will be, you can use the same, taking away the branch current from the input current. Here it's I2, and again same thing I've done to find out I5 and I6. So I was able to get more or less the same values here. There was no much there's no rounding error. So I got one more problem here, which is again not a simple one. So we have a 10 amps current source which divides into various branches. So the concept remains the same. You first have to find the equivalent resistance, and then find out the current, and you start finding the branch current. So before you do that, understand how the current gets divided. You got the main current I1, which is 10 amps here, divides into I3 and I2, which are these two currents, and I3 in turn divides into I4 and I5. So if you look at that, the first step you're going to do is you have to replace this. You have to replace this parallel circuit with the equivalent one, which I've done here. And again, you get a parallel circuit here. Replace that with. So here you can find out. So once you did that, so now you know the current I1 gets divided into these two branches here. So I3 and one I2. You can find out what is the value of I3 and I2. So I3, this I3 is the current that's getting divided between I4 and I5. So you just have to apply the same concept here. So the current I3, which is 4.41 amps, dividing into 1 and 2. So the formula you might have memorized by this time. So the current in a branch I4 is the other resistance divided by total resistance times the input current. I5 is the other resistor, which is 1, divided by total resistor times the current. So again, so I've got one more problem for you. Again, the concept remains the same. You first have to understand how the current gets divided, so which I have written here. And I'm not going to go through this step by step. It's the same steps again. You just have to identify the parallel circuit, then replace that with the equivalent resistor. So here I identified this as the first parallel circuit, and replacing that with equivalent resistance R1, and which I have shown here, and identified the center one as a parallel circuit and replace that with the equivalent circuit. Then when you did that, you'll end up having this as again parallel circuit, replace that with the equivalent circuit. Then you have got the simple circuit here, which you can now apply the current division algorithm. So the 5 amps current divides into I2 and I1. So you know how to do that. So once you reach that, you have to again backtrack. So now you know what's the value of I2. You can find what is I6 and I3. Once you find I6 and I3, you're going to find the I7 and I8. So it's a very, very similar concept. You just have to solve a couple of more problems so that you are comfortable. See, sometimes you'll be given the voltage source rather than the current source. Then you have to first apply all your knowledge on reducing this entire circuit into a simple series circuit, something like this way. Then you have to find out the current coming out of this battery, so that becomes your I. So once you do that, the whole method is the same. So you might be asked something like this as well.